Today we will be adding rational expressions. They will have the same denominators, so it won't be too bad. It'll get a little bit tougher when the denominators are different. So all we're going to do when we add fractions, again, you got to have the same denominator, and you notice that all the problems in today's lesson, they do have the same denominator. So when we add fractions, we just count up how many we end up having. How many of the 3b over b squareds we have. We got 5b over b squared, so we just count up how many b's you have. You got 3 b's on top, 5 b's on the bottom, or on top here, so we end up with 8 b's altogether. So notice all I did to get that 8b is I added these two numbers. So when I did that, I did 3b plus 5b. So I had 3b's and 5b's, and it's all over b squared. You don't change the denominator, just the numerator. 3b's and 5b's make 8b's. Well, we're not done yet. We still need to reduce the fractions. So you see how 8 and b are factors. They're numbers that are being multiplied. So we're able to cancel out this b here and take away 1 from the bottom. So we take away 1 here, and that leaves us with 1b on the bottom. So our final answer would be 8 over b. Take a look at the next one. Same sort of thing. You got n over 3n plus 5 over 3n. So you just count up how many n's you have. You got n plus 5n over 3n. So you keep the denominator the same, just add up the numerators. Well, when you add up n plus 5n, here you have 1n plus 5n makes 6n's altogether, all over 3n. So we can go ahead and reduce that fraction. We can take out that common factor of n. N's cancel out here. And 3 goes into 6 2 times. So everything canceled on the bottom, so you're left with 1. So 2 over 1 is the same thing as just 2. That would be our answer. So on this side, again, all you're doing is counting up how many x's you have. Here we have 3x over 8x squared plus x over 8x squared makes 3x plus 1x all over 8x squared. Well, we can add those numbers together because they have the same variable. So you count up how many x's you got. You got 4 x's altogether. So 4x over 8x squared. And so we can go ahead and reduce that fraction and take out those common factors of x. So this 1x here will cancel out 1x down below. And the 4 goes into the 8 2 times. So notice everything canceled out on top. So we've got 1 on top. We've got to make sure we show that. 1 over 2x would be our answer. Now let's take a look at the next problem here. So this next problem is a little bit different in that we have an expression on top rather than just one term. Here we have x squared minus 8x, but it's all over x minus 4, plus 8x plus 8 all over x minus 4. So let's do this. Let's go ahead and write this as one denominator. So I've got x squared minus 8x plus 2x plus 8 all over x minus 4. And so when we go ahead and do this problem, I want to collect like terms here. So you see I can't combine the x squared with anything, but I've got this negative 8x here, a positive 2x here, and I can combine those. I can add them together, just like I did over here. I got 3b plus 5b made 8b's. And so it's the same sort of concept. And so let's go ahead and combine those. We still have that x squared, but now it's a minus 6x because negative 8x plus 2x, subtract the two terms, more negatives than positives. This is all over 8. And then down below I still have this x minus 4. So I can go ahead and factor away. See, when you got a trinomial, we want to try to reduce this fraction. Let's go ahead and factor this trinomial. And so when I factor it, I get two binomials, and it factors to an x and an x for the x squared. And numbers that multiply to make 8 would be like 4 and 2. And you see how those add to make negative 6 if I put minus signs in front of those terms. And this is all over an x minus 4. So now we can go ahead and cancel. And so you see how the x minus 4s will cancel out, leaving me only with that x minus 2. And that would be my answer. Since it's over 1, you could write x minus 2 over 1, or just leave it as x minus 2. So it's the same sort of concept here. We have the same denominator, so we're just going to rewrite this as one fraction, 3y squared plus 3y, and this is all over y plus 1. So we go ahead, can't combine those two terms because they have different exponents on the variable y. However, there is a common factor. So you see how they both share a 3 and a y. That's what's in common between the two. And so that's what I'm going to take outside a parenthesis, do some division. Let's see what's left over. Y plus 1's left over. See how it works. 3 over 3 made just 1 y. Y squared over y leaves us just with this y as well. So 3y divided by 3y, and that made the 1. You can multiply back out. See, 3y times y makes 3y squared. 3y times 1 makes the 3y. Well, down below, we've got a y plus 1. And so now we can go ahead and cancel. So you see how the y plus 1's are canceling? They're gone. So what we have left is this 3y. Well, last problem here. We've got the same denominator again. Again, we're adding, so we just collect like terms. So I'm going to rewrite this as 2m plus 4 plus 2 all over an m squared minus 9. And so I can go ahead and collect some like terms there. So you see how the 4 and the 2 are going to end up adding together, and they make 6. So now I've got this, 2m plus 6 all over an m squared minus 9. And so from that point, I can go ahead and factor out that common factor. So you see how the common factor of 2 goes into both the 2m and the 6. And then also this denominator will end up factoring as well. But let's finish off the numerator first. 2m divided by 2 leaves us with m. 6 divided by 2 leaves us with 3. So there is our answer. Well, from there we need to factor this binomial. Now, since it's a difference of squares, it will factor as two binomials. And the factor form goes this way, m plus 3 and an m minus 3. And so from there we can go ahead and take out that common factor of the m plus 3. So those will cancel out. So let's see what's left on top. We've got a 2 on top and an m minus 3 on the bottom of the fraction. And there is our answer. So those are some of the problems you'll see on tonight's homework. Good luck.